Okay, so in this lesson, I'm going to talk about method overloading. This is a fast lesson. It's 5.4 in your textbook. It's not a long lesson. So method overloading. First of all, are we allowed to have two variables of the same name? So can I say int x equals 3, and then make another x, int x gets 5. Can I make two variables of the same name? No, right? It's already defined. Can't have two variables of the same name. It's like if you had two kids and you named them both the same name. It would be a very confusing household, right? So you never want two variables of the same name. What if it's a different data type, though? What if it was a different data type? So string x gets... Is that allowed? So put your hand up if you say that will work, because it's a different data type. We can have the same variable name with a different data type. Put your hand up if you say that will work. Put your hand up if it says it will not work. Okay. Let's play our favorite game show. Will it compile? No. So it doesn't matter that it's a different data type, because if you wanted to go, like, just give yourself an example. Now, you always have to think about, the rules have to make sense. Compiler rules have to make sense, right? If you were making the compiler, if you were making the language, would you allow this to happen? You wouldn't, because think of a counterexample where it would get confusing. So system.out.println x. Well, now, if we allowed this to happen, folks, if we allowed this to happen, which one would it print? We wouldn't know what to print, right? So that's why you would say, okay, that rule is not allowed. But what about method names? Now we know that method names, we have the same naming convention for good programming style as we do for variable names. Okay, Josh, Miles, please. Guys, settle down. Just made it to the video. So let's say, for example, we want to have good variable names, so we use Camelback format, just like variables. You know the difference, though, between a variable and a method. So, for example, here's how you know. You've actually used these before. So let's go string, more strings. String word gets hello. And let's go int a, so make an array, and we go 1, 2, 3. You've actually used these before. How do I know how many letters are in Word, other than just counting them here? Word dot length. Are there brackets or no brackets? There are brackets? Sure? Yeah? No brackets? Well, I this is the word, right? Word dot length. Brackets, yes? Okay. What if I went without the brackets? Would it work? No. What about the array? So if I go a dot length, brackets. Brackets? Is it brackets? A is the array. No. No brackets? Aha. Okay, so arrays have no brackets to the length field, and strings do have brackets. What do the brackets tell us? It's a method. The brackets tell us it's a method. So length is a method in the string class. Length is a method. We know what methods are. It's calling a method. It returns something. In this case, it returns an integer, if we were to look that up in the Java API. This is not a method. It's a variable or a field, because it has no brackets. So it's just a variable. So it's not calling a method. It's a field variable, or just a variable. Okay, so the method names are slightly different than variable names, they do follow the same naming convention, but we know when it's a method versus a variable because of the presence or non-presence of brackets. If there are brackets, you know it's a method. If there are no brackets, it's a variable. That's how Java knows. So again, you're putting yourself in the shoes of someone who was designing the language and saying, how do I know the difference between a variable and a method? Because they look the same, right? How do I know what it is? The brackets is the thing they tell you. And that's why even when we don't take parameters, we still have to put empty brackets for a method so that it indicates to the computer, okay, this is a method, not a variable. Now, that being said, how come we're allowed to have two methods with the same name? And the reason is because the parameter list has to be different in some way. Okay? Either by the number of parameters or the type of parameters. It has to be different in some way. Now, why does this work? Well, if you come down to the main method, here we call swap with names. I know it's commented out, but that's okay. You can see names is of type string array. So, this is one of the benefits of a high-level language. It's saying, oh, names is of type string array. It's something that Python does automatically a lot, right? And that's why a lot of you love Python. Java does these things sometimes, right? It goes, oh, automatically this is of type string array. So it goes, I'm going to call this method here because that's a string array. It doesn't fit into this one. Now, when I call swap up here, or did I erase it? If I called swap and I sent in two integers, it knows to call this one. And then what if I call swap with, like, say, 3 integers? What happens now? An error, because it says I won't be able to find a method that has 3 integers. So it says it here. Also learn how to read these errors, right? No suitable method found for swap int. So there's no swap that takes 3 integers. So we can have multiple methods with the same name. And you can see that it's beneficial to have multiple methods with the same name. Because in both of these methods, we're swapping things, right? So it's easier for the user to go, oh, it's just this one swap method. Now, you've seen this before. Believe it or not, you have benefited from this because you're like, well, what's the point? Why not just make it so they're not allowed to have the same names? The idea is it abstracts the details from the user. And now the user is not necessarily the end user, the person using the program. No. Not just the person using the program. Now the user is another programmer who might be using your program to call your methods. So, like you were a user. So, for example, you went let's say you went math.abs 5.6, and it gave you 5.6. If you went math.abs, what's ABS again? Absolute value. Good. So if I went negative 5.6, it gives me the positive value, 5.6. But what if I go math.abs of negative 5? It doesn't give you 5.0. So sometimes it's returning a double, and sometimes it's returning an int. What's going on here? Right? So we looked at it last year as this was the weird one that sometimes returns double and sometimes returns int. But you didn't have to learn. You didn't even know about methods when you learned this last year in grade 11. Do you remember? To you, there was just one ABS method. Believe it or not, how many ABS methods do you think there are? Who said 4? There are 4. So if you come here to the math class, so there's the Java API. Remember, you can Google search Java API. And I'm going to search here for math because it's math.abs. You come down here And you see ABS, 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 ABS. There are 4 different math methods called ABS, depending on what you give it. So if you give it a double, it returns a double. If you click on it, it'll actually give you the full method header. Public, static, double, ABS. So it gives you the full method header. Okay. If you give it a double, it returns a double, and it calls this method. If you give it an integer, let's go to the int one. If you give it an integer, it returns an integer, and you can see that here. Okay. It returns an integer if you give it an integer. It doesn't have to. So it'll call this one. If you give it an integer, it'll call this method. If you give it a long, it'll call this method. If you give it a double, it'll call that method. Now, you can also see that in things like, for example, I could make a bunch of different max methods that finds the highest of 2 numbers. Did I already make max up here? That was in another class. So I could go public, static, int max, and go int A, int B. And this will find the larger of the 2 between A and B. So I can go if A is greater than B, return A, else return B. Okay, so I could do that method, but then I could also want to call another method. Instead of saying max 2, instead of going max 2, and then this one is max 3 between 3 integers. Now the person who's calling this method, the person who's using these 2 methods, now would have to learn 2 different methods, right? So that's a bit of a pain. If you can use the concept of method overloading, now you can use the same method and either give it 3 or 2. And that's why, in some programming languages, like if anyone did grade 10 with me, I know a lot of you did grade 10 in JavaScript. And you remember there was some methods that you could call, like you could make a rectangle. So there was the rect commands, but there was like an optional parameter at the end where you could make it curved. So you could put that parameter in or you could leave it out. The reason why it was optional is because they actually had 2 methods running in the background. They didn't tell you that, right? So you could add that parameter. If you added that parameter, it would call the other method. If you didn't add that parameter, it would call the other method. And you didn't have to use 2 different commands. So how do we do this one with 3? Let's just do this one really fast. So you can say return max of A and B. But what about C? So I could call this method twice. So I could do that one really quickly and creatively like that, right? So first I'm going to find the max of A and B. I'm going to actually call this method from this method. So I'm going to call the maximum of A and B. It'll call this method and return the larger of the 2 here. And then once it replaces that with those 2, then I can come back here and then check that with C and call the max method yet again with those 2 numbers. Make sense? Does this line make sense? Any questions about that line? Pretty cool, right? So we could actually use this one and this one, but we have overloaded the method now. So if you give it 3, it's going to call this one. If you give it 2, it's going to call this one. And just finally, there's also this concept. Let's go back to the Java API here. Just really quickly, if you look at some of these, let's go back up to the top. Let's go back up to ABS. Now ABS has, let's just look at the double. Let's look at the ABS with the double and the ABS with the int. Let's focus on these two. So those two methods. If you provide it with an int, we know that are ints allowed to go into doubles? Can double accept an int? Yes, because ints are smaller than doubles. So if this method did not exist, you could still call the ABS method with an int, and it would go into that, it would call that method, and it would run that method. However, if this method didn't exist, so let's say we erased that method from our program, and then we called ABS with a double, it wouldn't work in the rest of them. Because conversely, a double can't go into an int. An int can go into double, but a double can't go into an int. But what if they both exist and we provide it with an int? Then which one does it call then? Then it goes to this concept I call the smallest shoe that fits. I just made that up. Okay, I call it the smallest shoe that fits. What does that mean? So imagine you are in a coma and you wake up 20 years from now, like The Walking Dead, and all of a sudden the world has been taken over by zombies, and you're in a hospital bed and you have no shoes, and there's all glass on the floor and everything like that. All the windows have been broken, and you're walking outside, so you need some shoes, but you don't have any shoes, so your feet are all getting damaged. Then all of a sudden you find some like size 15 shoes. They're not your size. You're size 10. You just find some size 15 shoes. Are you going to take them? Well, I mean, for now, they're still better than walking barefoot, right? So you'll take them. Maybe you'll add some like extra stuffing inside so that they don't slip off or something like that. But you'll take them. They're not the most comfortable, but it's better than walking on glass barefoot. So you take them. Then you're walking a little bit further on. So that's the idea of, okay, you don't have this method. You only have this one. And you're providing with an integer, which is smaller than a double. So it's not specific, but it'll go to that and it'll work. But then you come along the street and then you find some size 11 shoes that are just as nice. Do you swap them? You swap them. Okay, because it's better fit. So you'll take the smallest, and of course if you find a size 10, you'll take that too. But if it was a 9.5, you couldn't take it. Your foot doesn't fit inside at all. So it can't be even slightly smaller, but anything bigger could work. Okay, does that make sense? So the smallest method that allows the data types to fit, that's the one it will go to. So if they both exist and you provide it with an integer, it will go to that one. Even though it could go to this one, it could go to the smallest shoe that fits the one that's most specific to it. Does that make sense? All right. So that is the end of our 5.4 lesson on method overloading. So take a look at the homework there. I'll post that now so that it will be due tomorrow.